function identities. What are they and how are they used? That's the question that we're going to be trying to answer today. And I'm going to start this off by drawing you a right triangle, right? I have on the screen right now a right triangle. So one angle in that triangle is what we used to call 90 degrees. So let me just grab my stylus here. But in this new world where we don't talk 90 degrees anymore, this angle here is how big? Give it to me in radians, please. Anybody? What's the angle now in radians? Used to be in the old school days, 90 degrees, but now this is how big? The thing I just circled there, what's the size of that angle? It's pi over 2. Good. And also, just remember that a whole triangle is pi radians. What you used to call 180 degrees, we're now calling pi. So if I have pi over 2 in this corner right here, which you're right about, let me just change this a little bit here so I can write a little better on it. If this is pi over 2, then it means that these other two angles that we have left must also sum to pi over 2 because there's only pi over 2 left. So if one angle is theta, then the other angle is pi over 2 minus theta. Let me say that again. Pi over 2 is one of the angles in this right triangle. That's the right angle. If a whole triangle is pi, then what's left over, this is not an isosceles triangle, by the way. Don't take this to be isosceles. It's not like the one we did yesterday where the other two angles are equal. This is not isosceles. If what's left over is going to sum to pi, then if one of these angles is theta, the other angle is going to be pi over 2 minus theta. Hopefully that makes sense. So this triangle is now labeled. I've also labeled the three sides of the triangle. I've labeled one side A, that's the hypotenuse. I've labeled one side B, opposite to theta. I've labeled one side C, opposite to the angle that we're calling pi over 2 minus theta. So let's now use some SOHCAHTOA to refer to each of these angles, starting off with the angle theta. So the angle theta, if I took the sine of that angle, that would be equal to b over a, right? That's just opposite over hypotenuse. That's simple enough. If I took the cosine of that same angle, that's going to be equal to c over a. So that's the adjacent side over the hypotenuse. So far, so good. If I took the tangent of a, that's going to be the opposite side, which is b over c, which is the adjacent side. Again, all grade 10 stuff. Nobody should be struggling with this. We should all be good with that. I'm going to add one more, and that's the cotangent of theta. And that would just be the reciprocal ratio. So we talked about reciprocal ratios yesterday. The tangent is b over c, so the cotangent will be c over b. That's just the adjacent over the hypotenuse. That's just flipping over the b over c and making it c over b. So far, hopefully, so good. Let me check in with the room. Alexander, does that make sense? Is everything good with that so far, Alexander? Great. Okay. Now, let's switch over to the other angle up in the top corner. So the top corner is the pi over 2 minus theta. Let's take the sine of that. The sine of that angle is equal to c over a. So that's opposite over hypotenuse. All right, that's SOHCAHTOA again. The cosine of that angle is b over a. So that's the adjacent side b over the hypotenuse of a. The tangent of that angle, this is the pi over 2 minus theta angle, that's equal to c over b. Again, opposite over adjacent, nothing strange there. The cotangent, of course, is b over c. That's just flipping it over. Now, I want you to notice something. These two columns have some ratios that are identical. For instance, look at this one. This one says that b over a is equal to the sine of theta. This one says that b over a is equal to the cosine of pi over 2 minus theta. Now, if b over a is equal to both of those things, does that mean that sine of theta must be equal to the cosine of pi over 2 minus theta? We're going to get to that in the next column in a minute, but I want to show you some other things that are equal. The cosine of c is equal to c over a. And so is the sine of pi over 2 minus theta. So here's a c over a here. Here's a c over a here. And both of them are pointing to two different things. So those two things should be equal, right? Same thing here. There's a b over c in the first column. There's a b over c in the second column. They're both equal to two different things. So those two different things should be equal to each other. And finally, the cotangent of c over b, cotangent of theta is c over b, and also the tangent of pi over 2 minus theta is c over b. So those two things seem to be equal to each other. So what that means is that we can set up some what are called cofunction identities right away. One of those identities would be the following: that the sine of pi over 2 minus theta, this thing here, must be equal to this thing here, because they're both equal to c over a, right? I want to make sure that that makes sense to everybody. Daniel, how about you? Does what I just said make sense to you? That those two things should be equal. Daniel, are you there? Where's Daniel? Daniel, I'm looking for you. Where are you, Daniel? Okay. Does that make sense? What I just said makes sense. Are you following along with what we're doing? Does it make sense? Okay, good. Okay, so the second one, of course, should also make sense, that since this is b over a and this is b over a, that should make these two things equal to each other. The cosine of pi over 2 minus theta should be equal to the sine of theta. And then if you follow that logic along, then this should also be true, that the tangent of pi over 2 minus theta should be equal to the cotangent of theta. Why? Because the tangent of pi over 2 minus theta, right, is equal to c over b. This is also equal to c over b, so those two should be equal. And finally, and hopefully obviously, these two should be equal. The cotangent of pi over 2 minus theta is equal to the tan of theta. So those are what we call our cofunction identities. Ella, does that make sense? I want to make sure that everybody is on the same page with me. Ella, does that so far sound about right to you? Is Ella there? Where's Ella? Ella, where are you? Ella going once. What happened to Ella? Where is Ella? Come on, folks. You're supposed to stay not only logged in, but totally plugged into what we're doing. So, Ella, I really need to hear from you. Let me check in with somebody else, but I need to hear from Ella as well. Kelvin, how about you? You're there. Okay. Could you please explain how you got there to be equal again? Sure, Davina. Thank you for the question. So, Davina's question is, could I please explain how they will be equal again? I'm quite fine with that. Ella, are you there with us now? Still not there. Okay. So let me take an example, Davina. Let's take the fact that, and there's a b over a in the first column, right? That the sine of theta is equal to b over a, right? In the second column, there's another b over a that's equal to something else. That's equal to the cosine of pi over 2 minus theta. Now, if two things are equal to two other things, then those two other things have to be equal to each other. I'll give you an example. So if a is equal to b, and let's say t is also equal to b, right? That must mean the conclusion of that is that a must be equal to t, because everything is equal. Since b is equal to a and since b is also equal to t, then a must be equal to t, right? Does that kind of make sense, Davina? Right? Okay, no problem. Okay, so I'm going to give you a few more that are equal without actually proving them, right? But I've just proven why these in the third column are equal, that the sine of pi over 2 minus theta is equal to the cosine of theta, and so on and so forth. Here are a few more that you're supposed to know. That the cosecant, which of course is the reciprocal of sine, of pi over 2 minus theta is equal to the secant of theta, and also that the secant of pi over 2 minus theta is equal to the cosecant of theta. I'm not going to prove that to you, but I'm just going to give you that. That is one of the cofunctions that you're supposed to know. Okay? Now, let's extend this beyond just simply the first quadrant, because everything we've looked at so far, if I take pi over 2 and I minus something from it, I'm going to get an acute angle. Now, remind you that pi over 2 is the same thing as 90 degrees. Let me just remind you of that. So if I were to subtract something from pi over 2, then I'm going to end up with an acute angle. But sometimes angles are not acute, and we need to look at what happens in quadrants outside of the first quadrant. The first quadrant has all the acute angles between 0 and pi over 2 are all acute angles. Acute, of course, means less than pi over 2. So here's what we're going to do now. We're going to ask you which quadrant, well, I just kind of answered the question, which quadrant is pi over 2 minus theta in? Well, that would be the first quadrant, and that's why you see that little line there. I'll just highlight it for you. That's why you see this little line here, right, representing a first quadrant angle. Pi over 2 minus theta must be in the first quadrant, unless, of course, theta is itself bigger than pi over 2. It's just going to be something in the first quadrant. Pi over 2 plus, though, it means that you're going to be at pi over 2, which is right upon the x on the y-axis, and you're going to go a little bit beyond that into the second quadrant. That's what this line is saying here. All right, so that's a second quadrant angle. This is now 3 pi over 2, so now I'm going to be going from the negative side of the y-axis, and I'm going to go back into that third quadrant. So that's a third quadrant angle. Notice that in all of these cases, the angle I'm measuring from is a y-axis. So I'm going from the y-axis, either going right or going left. So when I was at pi over 2, which is the y-axis on the positive side, if I went to the right of that, I'd be pi over 2 minus. If I went to the left of that, I'd be pi over 2 plus. If I'm going to go from the negative side of the y-axis, the negative side of the y-axis is 3 pi over 2, what we used to call 270 degrees back in the old days, right? Old days meaning grade 11, by the way. So if I were to take 3 pi over 2 minus theta, I'm in the third quadrant. So that would be somewhere inside here. That's why you have that line there. If I were to go 3 pi over 2 plus theta, I'm in the fourth quadrant. And that's why we have this line right here. Okay, so I'm going to relate all of this now to the cast rule. So we know that in the first quadrant, we talked about this yesterday, all the ratios are positive. So that means that in Q2, sine is positive. So pi over 2 plus theta, which is the second quadrant, right? Sine is positive. In Q3, which is the 3 pi over 2 minus theta, remember that 3 pi over 2 minus theta means I'm in the third quadrant. Tangent is positive. If I were to do Q4, then we're talking about 3 pi over 2 plus theta, cosine is positive. Let me sort of take a little deep breath here and make sure that everybody is with me on this. Chrisania, are we good so far? Are we good so far on that, Chrisania? Does that make sense, what I just said about each of those quadrants? Great. All right, so we know that Q1, they're all positive, and Q1 is where you have pi over 2 minus theta. Q2 is pi over 2 plus theta, that's where sine is positive. Q3 is 3 pi over 2 minus, which is where tan is positive. And Q4 is 3 pi over 2 plus, where cosine is positive. So that's just the whole cast rule stuff that we talked about yesterday. Okay, now let's now relate that to each of these cofunction identities. Here's what this means. In quadrant 1, the sine of pi over 2 minus theta is just equal to the cosine of theta. We talked about that. That was on the very first page. In quadrant 1, the cosine of pi over 2 minus theta is equal to the sine of theta. We talked about that on the first page as well. Nothing new there. The tan was equal to the cotangent, and the cotangent was equal to the tangent. So that's all repeating the stuff that we did from the first page. Nothing new there. Well, look at what happens in quadrant 2. In quadrant 2, sine is still cosine. Nothing changed there. Why? Because sine is positive in quadrant 2. But look at the cosine. The cosine of pi over 2 plus theta is no longer just sine, it's now minus sine. Can Q4 also represent as 2 pi minus theta? Good question, Hussein, except I'm going to say no, and we'll talk about why it's no on the last slide, because you're always measuring for cofunctions from the y-axis, never from the x-axis. Okay? That's why it cannot be 2 pi minus theta. We have to measure from the y-axis, not the x-axis. All right? Okay, so cosine of pi over 2 plus theta is equal to minus sine. Hopefully that makes sense. Why is it minus? It's minus because we're saying that we're in the second quadrant. So if it's a pi over 2 plus, it's the second quadrant, and therefore cosine is still going to change to sine, but it's not going to be minus sine. Well, what do you think happens to tan? The tan, remember we were in the second quadrant again, the tan of pi over 2 plus theta is now minus cotangent theta. And also, cotangent of pi over 2 plus theta is also equal to minus tan theta. Whoa. Okay, let me sort of, as Jamaicans say, haul and pull up there for a second. Are we all following that? Sebastian, how about you? Did that make sense? Right? Sebastian, are you there with us? It does. Let's go to quadrant 3 now and see what's happening in quadrant 3. Remember, quadrant 3 is where tan is positive. So the sine of 3 pi over 2 minus theta, remember 3 pi over 2 minus theta is in quadrant 3, you have that becomes minus cosine. So sine and cosine are still cofunctions of each other. That's not changing, but the sine becomes minus. Right? The sine of this thing becomes minus cosine. The cosine is also minus sine, but the tangent is going to become cotangent, and the cotangent is going to become tangent. These stay positive. These do not become negative. Go to quadrant 4. I hope that people could predict what's going to happen in quadrant 4, but let me go through it anyway. In quadrant 4, the sine of 3 pi over 2 plus theta is going to be equal to minus cosine theta. Okay? The cosine of 3 pi over 2 plus theta is equal to the sine of theta because it is in the fourth quadrant. And in the fourth quadrant, cosine is positive. So it becomes sine, but it's positive. Tan becomes negative, and cotangent becomes negative. Okay? So I'm hoping that all makes sense. Now, how these things are going to be put to use, I'll get to when we get to the next class, which will be the period, the block, I guess, block 2 class. But I want to make sure that I don't want you to memorize these, right? There's a logic to this that I want you to understand. The logic of this is that you will, depending on the quadrant, you're going to determine whether the cofunction is positive or negative, and you're always deviating from the y-axis, never from the x-axis, always from the y-axis. So whether you're on the positive side of the y-axis or the negative side of the y-axis, you're always deviating from the y-axis. Okay? So I want to make sure everybody's clear on that. No, I think I just want to go a little bit further with this and to answer the question that Hussein was asking about 2 pi minus theta. Let me point out the following to you, right? If I was going to be going from first quadrant, second, like just what we just did a few minutes ago, but we're now going measuring from the x-axis, then what would happen is that you're not changing to a cofunction anymore, right? So you talked about 2 pi minus theta a few minutes ago, Hussein. So if I was in the first quadrant, I was measuring from the x-axis, then that would just be theta here. It's not pi over 2 minus, it's just theta. And that means that what you're going to have is that in quadrant 2, right? Right, which is where you have pi. So this is measuring from the x-axis now. In quadrant 2, the sine is just still simply sine. We're not making it any different from what it was before. Sine is not going to become cosine because it's not a cofunction. It's just simply what happens when you deviate from the x-axis. So sine of pi over 2 minus theta is still equal to sine, and it's still positive because it's in the second quadrant. The cosine of pi over 2 minus theta is equal to minus cosine. Notice that we're not talking about sine becoming cosine and cosine becoming sine. They're still going to be the same thing that they were before. But because I'm deviating now from the x-axis, then they're still the same. There's, cosine is still cosine, but now they're going to change sine as in SIGN. So cosine of pi over 2 minus theta is kind of what we're doing yesterday, by the way. We're saying that second quadrant's cosines are going to be negative. And the tan of an angle added on to so this is like your related acute angles, really what this is, just like the related acute angles from yesterday, that the tan is going to be negative. And in quadrant 3, Sine is still, sine is going to be minus sine. Cosine is going to be minus cosine because that's quadrant 3. Tan is going to be tan because it's quadrant 3. Oh, sorry, I didn't mean to end the presentation there. All right, but let me stop sharing that for now. Let me stop sharing that